Welcome back. We're on day 2 of section 4, 1 and 2 notes, and we're on the bottom of page 3 of your note packet. And we're going to start with complementary events. So it says the complement of an event, denoted by A with a bar on top, consists of all outcomes at which A does not occur. Event A does not happen. So in other words, if I was talking about rolling a dice and getting a 3, so the probability of getting a 3 would be 1 out of 6. The ones that didn't occur was if I get a 1, 2, 4, 5, or 6. So that's what complementary events are. It's one that doesn't occur. So find the complement of each event. I think you'll get a better idea of what we're talking about with this one. So if I roll a die and get a 4, the complement of that event would be rolling a die and getting a 1, 2, 3, 5, or 6. That would be the complement of this event. Selecting a letter and getting a vowel, the complement of that event would be selecting a letter and getting a consonant. So you assume Y is a consonant for our purposes when we're doing these counting problems. And C, selecting a month that begins with J. Well, months that begin with J are January, June, July, and that. So a month that doesn't begin with a J would be February, March, April, May, August, September, October, November, and December. Selecting a day of the week and getting a weekday, the complement of that would be getting a weekend day, so Saturday or Sunday. There's what a complement is. I think you get the idea about that. Rule of complementary events. If you take an event plus its complement, it's going to equal 1. Well, if you think about the probability of getting an event and the probability of not happening, they're going to always equal out to 1. Let's think about the die problem, the dice. If you roll a die and you get the probability of getting a 3 is 1 out of 6. The probability of not getting a 3 would be 5 out of 6, and if you add those two together, it's always going to equal to 1. What you can do is use this to find the probability of the complement by subtracting the probability of the event from 1. So that's where that leads. So if we look at a Venn diagrams have these circles. If our total area is 1, the probability of A is in this Venn circle here. The probability of the complement is 1 minus that probability. That's a visual for you. So let's look at example 411. If the probability that a person lives in an industrialized country is a fifth, find the probability that the person does not live in an industrialized country. This should totally make sense to you. You would just subtract that from 1. If 1 out of 5 is the probability they live in an industrialized country, then 4 out of 5 is going to be the probability that they don't. So you take the probability of the complement is equaling 1 minus the probability of your event. So 1 minus 1/5 is going to be 4/5. So that would be the probability of a person not living in an industrialized country would be 4/5. Empirical probability. So this is the second type of probability, and I think it's kind of interesting. Classical probability assumes that certain outcomes are equally likely, but empirical probability relies on actual experience or observation to determine the likelihood of outcomes. So they actually do the experiment and record the results in a frequency distribution. That's why it's also known as a relative frequency approximation of probability. So here we do. Conduct or observe a procedure and count the number of times it actually occurs. Based on these results, P of A is approximated as the frequency for the class over the total frequencies in the distribution. So if we look at this first example, 412, in the soft drink survey described here, find the probability that a person responded no. Here's the response. They could have said yes, no, undecided, and the total. So we've got frequency that 15 people said yes, 8 people said no, 2 were undecided, but the total is 25. And we would do our probability of no would be 8 out of 25. I think that's pretty self-explanatory. Let's move on. Sample of 50 people, 21 had type O, 22 had type A, 5 had type B, 2 had type AB. Set up a frequency distribution. That's a fancy word for a table to show the following probabilities. So we're going to have blood type and frequency. Blood type, O, A, B, AB, and the total for the last line, and frequency. We put our numbers in there, and then we can do all our probabilities that we need to. Type O blood, there were 21 out of 50. So the probability of type O is 21 out of 50. Type B is 5 out of 50. Neither type A or O. Now there's a couple ways to think about this. If it's neither type A or O, then it could be type B or AB. So I got 7 out of 50. 5 plus 2 out of 50. Does not have type AB. So if I look, AB is 2, there's a couple ways you could think about this. If I add these, I get 48 out of 50. So I did 1, you could also think of it as 1 minus 2 out of 50, which is 48 out of 50. When you reduce that, that's 24 out of 25. Do example 414 on your own. So on that example, I'll be checking that off your notes to see if you understand how to set up a frequency distribution and do that empirical probability. Let's look at this one. It can also be found by using a relative frequency distribution. In this case, your division has already been done and it's been divided and put as a decimal. So if I was looking for the probability of a person who responded no, given this frequency chart, frequency distribution, I know it's 8 out of 25, but if you divided those, you'd get 0.32. So there it is. Probability of no is 0.32. 32%. If you notice, here's all the probabilities. They add up to 1. Law of large numbers. This is on your sheet. But what this is saying is that as a procedure is repeated again and again, the relative frequency probability of an event tends to approach the actual probability. So if you roll a die so many times, eventually the probability of getting a 3 is going to be 1 out of 6. It may jostle around and get around 1/6, but the more often you do it, the closer it's going to get to the actual probability. And it happens with games of chance and that. The other thing is the subjective probability. That was the third type. The probability of event A is estimated by using knowledge of relevant circumstances. So a lot of people, when they're getting insurance, they get sold a bill of goods like you need this much insurance and so on. They always want to sell you a lot of insurance. And we worry about things that perhaps would never happen to us. For example, people worry about, nuclear radiation when they live close to a nuclear plant, but when they do the probability, it's very low, whereas the probability of dying because you're too heavy or you get heart disease is much higher. And so they worry about cancer in that, and they worry about global warming, and then you look at the probability of the earth heating up and it's not that much. If you watch that Doomsday Preppers show, a lot of people worry about having a tornado or a flood, and this is where knowing what area, how likely is it for it to have an earthquake, a tornado, a flood, or a fire, will help you determine the right level of insurance for you. So that's just one real-life application of probability. Okay, that's it for that first couple sections, and I will see you later.